Hey folks, this is the second half of Unit 2, Lesson 2. This is just kind of a few short examples on more composite area questions. And in these ones, we're going to have to deal with what's called partial circles. So we had a few questions in Unit 1 when we did our composite area where there was a circle, most often a circle cut out of something. Because when you add a circle on, that tends to give kind of funny shapes, but sometimes you are only adding on part of a circle, and that's what we're going to look at today. So the first thing I want you guys to try on your own, take 3 or 4 minutes and just give these a try. Find the area of each of these shapes. So pause this, get your pink sheets out, and give each one of these questions a try, and then you'll restart the video. Okay, so I'm going to assume that you have attempted these questions, and now we'll take a look at what the answers are. So the first shape is kind of like a circle. So I know that the area of a circle is pi r squared. But this is not a circle. I don't have a whole circle. I have half of a circle. So what I'm going to do is adjust this formula. Because I only want half the circle, I'm going to divide my answer by 2. And the other important piece here is that I don't have the radius. The radius, remember, is just halfway, whereas this was the whole 18 centimeters all the way across. So the radius here is 9 centimeters. So remember, when calculating area, you write down your formula, you put in your numbers, and then you get an answer to 2 decimal places with units. So I'm just going to pull out my calculator here, and I'm going to do pi times 9 squared divided by 2. And I get 127.23, and this would be centimeters squared. If you were very close to that, but you typed in 3.14 instead of using your pi button, that is totally fine. Okay, so the second one, this one's looking at that one formula that can be a little bit trickier than the others, and that's the trapezoid. This is a plus b times h divided by 2. So remember, the top is your A, the bottom is your B, and perpendicular up and down is your H. So here I've got 6 plus 12 times 4 divided by 2. And this is the one that sometimes needs a little bit extra steps just to make sure you do BEDMAS properly. So instead of doing that all in one step, I added the 6 and 12 to get 18. Then multiply by 4, divide by 2, and that's 36, and this is also centimeters squared. So this first one is actually really what we're going to be looking at today. In particular, we're going to be doing composite area, but in particular questions where we've got this kind of divided by 2, sometimes a divided by 4 if you only have 1/4 of a circle. Okay. So again, whenever we're doing composite area questions, you have to make a plan. So my plan here, we've got this shape. Looks kind of like a basketball court, something that's like laid out in a gym, but who knows, could be anything. But I'm going to plan that this shape I'm going to get by adding up a rectangle and half of a circle on the end. That's not the best semicircle drawing there ever was, but we're just going to kind of go with it. So that's my plan. You don't have to write out a bunch of stuff. You don't have to do anything too tricky. Just draw a sketch of what you're going to be finding. Now, I'm going to do first the rectangle. So this is 8 and that's 10. And I know that area is length times width for a rectangle. So it's 10 times 8, which is 80 feet squared. The next piece is this semicircle, so half of a circle. So we know that this whole distance across is 8. So what will my radius be? Hopefully you guys can notice that that 8 is the diameter. So I'm going to have a radius of 4 for just that half. So the area of a circle normally is pi r squared, but I don't have a whole circle. I only have half a circle, so I'm dividing it by 2. It's just that little adjustment on your equation that you have to make. So here, if I do pi times 4 squared divided by 2, I get about 25.13, and that would be feet squared. So my first step was my plan. I figured out I'm going to add a rectangle and half of a circle. My second step was the calculating actually the rectangle and the half circle. And my last step is to combine. So then I'll put total A equals 80 plus 25.13. So that's going to be 105.13 feet squared. Oh, and that should be approximate because I did round off that one. And that's all there is to it. The extra thing that we're doing in this unit in particular is having parts of circles. Half a circle or a quarter of a circle. Okay, so again, it's important to lay out your plan. Oh. I'm going to say that the area is this long rectangle plus the half of a circle that's on top. That's my plan. I'm just going to kind of cut this across. And I will have to figure out what this radius is, because I don't actually know right now. We'll figure that out though. So when I'm doing my calculations, I've got a rectangle and half of a circle. Now the rectangle, sometimes it can help to kind of color code these, like there we've got this blue rectangle and it's 2 centimeters high and 7 centimeters long. So that's not too tricky to find the area of. Length times width. So 7 times 2, which is 14 centimeters squared for the area just of that part that I've shaded blue. Now, think about how we could find the radius. I've got 2 other measurements that I haven't used yet. I know there's 1 centimeter there and 2 centimeters over there. So I might look at this whole distance across and say that 7 minus 1 minus 2, which is 4 centimeters. So that tells me that if I take off this 1 and this 2 from the whole 7 going across, I've got 4 centimeters left for the diameter. But I have to know the radius. So R is 2 centimeters, half, right? Divide that by 2. So now I'm going to use my formula for circles, pi r squared, but I don't have a whole circle, so I have to divide my answer in half because I only have half of a circle. So then pi times 2 squared divided by 2. And put that into your calculator, rounding to 2 decimal places, you should get 6.28, and that'll be centimeters squared. So the rectangle part on the bottom was 14, the half of a circle on top was 6.28. Now I will add up for the total. So 14 plus 6.28, again, looking back at what my plan was. I found the rectangle, I found the half of a circle, now I'm adding them up. So I get 20.28 centimeters squared, and that is rounded off because the 6.28 is rounded off. So this one is a kind of interesting. We want to find just the shaded area on between the two circles. How much is that kind of ring or washer shape? So what would your plan be for that, I wonder? I kind of feel like we would have that the area would be the big circle minus the inside cut out part. Imagine you had a piece of construction paper and you cut a circle out of it. How could you make this shape? You would have a circle and then you would cut out a smaller circle from inside. And these different radiuses, I think, are a good way of showing that. So this first one has a radius of 50. The next one has a radius of 36. So we're going to take the big circle minus the little circle, and that's how much is left over. So in the last couple, I had to divide by 2 because I was only using half of a circle. But here, I'm actually using a whole circle, so I don't actually have to divide by 2 at all. I'm going to have pi times 50 squared. And that ends up being 7,853.98 square feet. And what about the 36? We'll do that calculation as well. Pi r squared. So I get pi times 36 squared. So this is 4,071.50 feet squared. So then I will figure out the total. So the total area is the big amount, the 7,853, minus the smaller amount, 4,071, with decimals. So I come up with 3,782.48 square feet. That's how much would be left after you cut out that middle part. Okay, one more example in this lesson. Now this plan is a little bit different. We've kind of got 3 different parts maybe. My area could equal this top piece plus the rectangle plus the bottom piece. Now each of those top and bottom, I think we could say that these are the same. And now we just kind of have to find the area of each. I hope you're okay with saying that that's actually 1/4 of a circle. So I'm going to find the areas of those. So the first one, actually I'm really only going to find the area of this one, because the other one's the exact same, just kind of reflected. So there's my 1/4 of a circle. This shows me that the radius is 4. So I'm going to take my circle formula, pi r squared, and I'm dividing it by 4 because this is only 1/4 of a circle. So then I'll have pi times 4 squared divided by 4. Which ends up being 12.8 3.57. Again, if you're using 3.14 versus pi button, it may be a little bit different. So that's the area of the top and bottom. These, like, I'll color code that, like blue, that those pieces are exactly the same. So those are each 12.57. The other piece that I have to calculate is this rectangle, which doesn't look too tricky, right? Rectangles, that's pretty easy. But this is 4 centimeters. And I'm told that this whole distance up and down is 10. But I'm not actually given this amount. Hopefully you can see that this is the same because that's both the radius of the circle. So we would have to subtract 10 minus 4 equals 6 centimeters for that up and down part. And then we'll find the area of that, 6 times 4, which is 24 centimeters squared. Then we'll follow our plan to get the total. So the area is going to be 12.57 plus 24 plus 12.57 again. And I end up getting 49.14 centimeters squared for my total area. So hopefully that makes sense to you. You will have a bit of time to work on the rest of these lesson 2 practice questions as well.